Hi, one of the most important things that you need to be able to do is to be able to plot a quadratic such as y is equal to x squared minus x minus 6. So in this video we're going to learn how to plot a simple quadratic and find the coordinates of the minimum point from the graph, and then draw on and label a line of symmetry and find the solutions of the quadratic when it's equal to 0. So the question is, copy and complete the table below for y is equal to x squared minus x minus 6 for values of x from minus 3 to 4. So there's our table. Using the table, plot a graph of y is equal to x squared minus x minus 6 for values of x from minus 3 to 4. Using the graph, calculate the coordinates of the minimum point. Draw on your graph and label the line of symmetry, and use your graph to find the solutions of the equation x squared minus x minus 6 is equal to 0. So we've got y is equal to x squared minus x minus 6. We've got this table. The table's here to help us actually work out when x is equal to minus 3, what will be the y coordinates. So these are what these two boxes are, and we use these boxes here to help us. So the first one, we've got to work out x squared. So minus 3 squared is 9, minus 2 squared is plus 4, minus 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Then we got to do minus x, so minus minus 3 is 3, minus minus 2 is 2, minus minus 1 is 1, minus 0 is 0, and then this becomes minus 1, minus 2, minus 3, and minus 4. Here it just says minus 6, so everywhere along here we just write in minus 6. Right, so what we do now is we take each column and we add them up to work out what the y coordinate would be. So what 9 plus 3 is 12, take away 6 is 6. 4 plus 2 is 10, 10 take away 6 is 0. 1 plus 1 is 2, 2 take away 6 is minus 4. 0 plus 0 is 0, 0 minus 6 is minus 6. 1 plus minus 1 is 0, 0 plus minus 6 is minus 6. 4 plus minus 2 is 2, 2 minus 6 is minus 4. 9 minus 3 is 6, 6 minus 6 is 0. 16 minus 4 is 12, take away another 6, we get 6. Notice that there is some symmetry here. So we now plot the points. Minus 3, 6. Right, we don't need the bits in the middle, we just need the x and the y coordinate. Minus 2, 0. Minus 1, minus 4. 0, minus 6. 1, minus 6. 2, minus 4. 3, 0, and 4, 6. Right, so these are the plot points we're now going to plot on our graph in part B. That's all we need from the table. So I'm going to write them again at the top. So we've got some graph paper here now. Right, we need to draw ourselves a set of axes which fit on our graph paper. So I'm going to draw, these are my sets of axes. You need to label the endpoint here x and the endpoint here y. This is the x axis, this is the y axis. And I'm going to label on the points here, minus 3, minus 2, minus 1, 1, 2, 3, 4, because those are the ones we need from minus 3 to 4. I'm going to need at least down to minus 6 and then up to 6 on my y-axis. I'm just going to go down 2 more. So I'm going to label them that way. Now, although the scale is the same all the way through here, it is different to this axis here, and that's okay, provided that the scale along one axis is the same. So what I've got here is this distance is minus 2 on this axis, but it is 1 on the x-axis. It doesn't matter, as long as I've got the same scale all the way across the axis and the same scale all the way across the y-axis. So I can now proceed to mark on the point. So minus 3, x first, 6, that's that point there. Minus 2, 0 is that point there. Minus 1, minus 4, which is that point there. 0, minus 6, which is that point there. 1, minus 4, which is, sorry, 1 minus 6, which again is that point there. Okay, 2 minus 4 is that point there. 3, 0 is that point there. And 4, 6 is that point there. Okay, we can see that this is quite symmetrical, but the thing is, if I join up the bottom 2 points, I'm just going to get a straight line. In fact, it does actually go slightly lower. So it is worth your while, using the symmetry, that we should check an extra point. And the extra point you need to check is the halfway between these 2 points here, which is 0.5. Now, you don't always have to check an extra point. Here we've got 2 points in the same position. So our function was y is equal to x squared minus x minus 6. So instead of x, I now do y is equal to 0.5 squared minus 0.5 minus 6. Now 0.5 squared on my calculator gives me 0.25 minus 0.5 minus 6. And if I work that out, I'm going to get minus 6.25. So it's worth plotting on 0.5 minus 6.25. So minus 0.5 minus 6.25, so it's just going to be slightly lower. And now you can see I've got sort of a U shape. So join all the points up with a smooth curve, and that takes a little bit of skill, a little bit of practice when you first do it. Maybe one way is to turn your paper upside down and keep your wrist on the paper as you do it. Make sure you use a pencil so that you can rub out any mistakes that you make. So there we go, and then at one end you should label the graph y is equal to x squared minus x minus 6. Right, the line of symmetry, so you can see if I draw a line from all the way here, then this is a line of symmetry. Okay, so one thing about a quadratic, it always happens at this particular point is the line of symmetry goes through it. This point here has a special name, it's called the vertex. Alright, and this is called the line of symmetry, and its equation will be x is equal to 0.5, because everywhere along it, x is equal to 0.5. It doesn't matter what the y coordinate is, x is always equal to 0.5. So writing down the answer. The last part says that we need to solve the solutions of x squared minus x minus 6 is equal to 0. And this is just to see what we're actually doing, because normally we solve this using a different method, which we're going to look at in a later video. But if I write down the graph that I've drawn, x squared minus x minus 6, y is equal to 0. Where is y equal to 0? Well, y is equal to 0 is actually this line here, which is the x-axis, because every y-coordinate here is equal to 0. So where does my curve cut the x-axis? Well, it cuts the x-axis here, at this point here, which has just turned orange, and this point here, which is just turned orange. So there are two solutions. Now, with a quadratic, you can either have, when it's equal to 0, you can have two solutions, one solution, or no solutions. If there's no solutions, the quadratic's up here. If it's one solution, the quadratic will just touch the axis and go back up. In another video, we'll look up quadratics that go that way around as well. So that gives me x is equal to minus 2, or x is equal to 3. Okay, this has been a video to show you how to plot the points of a quadratic from a table, and then use that to look at some of the characteristics such as the line of symmetry, the coordinates of the vertex, which is that point there, and its solutions when it is equal to 0. I hope you have understood and hope you've been able to follow, and I thank you very much for watching.